Hey, what is this? So I'm sharing my screen. Guys, I hope all of you are able to see my screen. Yeah. Sure. So till now we have covered embedded systems, C language, CAN, and UDS and AutoSAR. So majorly I can say they are the technical topics. What it is very important for all the automotive engineers, even if it is the testing or the development. Okay. So today we will be seeing at the ADAS project, which is a real-time project, how the requirements will be there, and how we will be doing the testing, not testing actually, the implementation part we will be seeing it. Okay, so after that we have only the topic left is the tools one. So how exactly what and all tools it is needed for all doing all our daily activities for the real-time projects is what it will be left. So most probably today we will finish this ADAS project, and I may need one or two classes for this. But if time permits, tomorrow itself I need very long class, which will be more than 3 hours actually. Why? Because I need to take the remote control of other companies' PCs, and I need to explain this actually. So as I doesn't have all these tools access, so I may need to take other PC control, and I need to explain. So instead of taking the access every day, I'm planning to take at least one day, which will be very long class. Of course, we can have the intermediate breaks also in between. That's doesn't problem for me. But I wanted to finish all this, at least until this zero. We might need to finish within a one class. It may finish within 2 hours also. It's fine. If not, it may also extend. It's up to you how the guys will be coming up with the question and answers. Okay, trace 32 on the Canoe I will be showing in my PC. That's a doesn't problem. Canoe, all of you guys have might have seen already for the CAN and UDS classes. Again, it's a fine. I will be showing once again. It will not take much time for me. On trace 32 also, I will be showing how to flash the software and all. These two things I can handle in my PC also, but the remaining things I cannot handle in my PC. That's the problem. If anyone is going particularly for the vector cast, I may arrange the separate class also for the vector cast itself. It may take 1 or 1.5 hours. If not, I have the already readily available recorded video which was done for the previous sessions. So that also I can provide. If it is purely depends on the license availability. If license is not, if I'm not able to fetch the license, then definitely I will be giving the 1.5 hour video for all of you. Okay, guys, any doubts? So today we will be going to see the ADAS project. Any doubts to anyone? Not only for today. If any doubts in the previous classes also, it's a fine. I can able to answer you. Guys, any doubts till now? If not, I think then we'll start with the project actually.
No, bro.
Fine. So majorly what I can say is these are the topics which we are going to see today. So what is the project? And then in that project, what is exactly the ADAS? What is the importance of it in the automotive industry? And we will be just seeing TSR and some CAN related in CAN related requirements, CAN or UDS related requirements. We will be seeing it, and then we will be seeing all of them with the coding perspective as well. Okay. So I may not be having the AAB features requirements, but definitely I will show you the TSR requirements as well as the code. Okay. and how exactly apart from these topics, and also we will be seeing how the project structure will be there, how the project structure will be there with respect to requirement structure, and also how the code structure will be there, the folders, how we will be organizing in the code, we will be seeing it. You might have seen already, but it is once again you can just remember all of them, that's not a problem. Okay. And I think yeah, this is the major scope for today. We'll see if any other new topics are coming in in middle of the class, that also we will be taking care, no problem. Got it. Yeah, can anyone tell me what is the project basically? What is the project? Sorry?
Automatic driving system.
No. This is fine. This automatic driver assistance system is fine. So basically, what do you mean by the project? So we will be hearing here and there, right, the project. If you are constructing a metro also, that they will call it as a project. Project means what?
You're developing something to
Correct.
use. Mm.
Correct. So developing something for some purpose, okay, that purpose might be anything. It might be for the metro construction, it might be for the ADAS or future development, it might be for the engine development, whatever it will be. If you are accepting one mission, one task, particularly if I'm saying for a longer period of time, then we call that as a project. Correct. So in that similar way, so we will be handling the multiple projects of the development. Okay, so one among them is the ADAS project, what I can say. Okay, the company, whichever it might be, company wise, if anyone experienced is that, that's fine, but for non-experienced guys, I just wanted to tell all these basic terms also. Tomorrow they should not get surprised that what is this, all these terms. Okay, so inside company we will be having the departments. So inside departments we will have the multiple projects. Okay, so this department they might call active safety department. So inside that, the ADAS project is there. This ADAS project again for the different OEMs also they will be handling it. So one is for the Ford, one is for the GM, one is for the Tesla, one is for Kia, Hyundai Motors. So this ADAS project might be same with a little bit differences. They will be handling it for the different OEMs. Okay, same software will be there, but very minute changes for the different OEMs to fit this particular ECU into their vehicles. Okay, so this everyone, if you are handling project for Ford, that will become one project. Handling project for GM, that will become another project. Project 1, 2, 3, like that. Okay, that is up to us how we are naming them. Okay, some guys in this perspective itself, they will be calling ADAS underscore Ford, ADAS underscore GM, ADAS underscore Kia, something like that. Okay, got it. Any doubts still here? So next, what is next? What is an ADAS? Can anyone tell me what is this ADAS? The term?
Automotive assistant driving assistance.
No. Driving assistance is fine.
Advanced driving assistance.
Perfect. Advanced driver assistance systems. Driver assistance systems. Advanced driver assistance systems. Advanced System DA, ADAS, ADAS. Okay, getting it? I hope all these things we have already discussed in our very first class itself. Yeah, just try to recollect all of those. If you have the videos, so just go through once again. Okay, all these recorded videos are there with my team, so you can ask them for your access, and they will be able to provide you the access if you are not able to see in the Skype. In Skype, it will be going to delete for after 30 days. Okay, that access will be there for you guys for only for 30 days. So the first class was happened more than 30 days back. So definitely, I'm sure it will not be available as of now. If it is not there, if anyone is needed it, then definitely ask any one of our team so that they will provide access to you. Okay, fine. So this ADAS part we have discussed the basics of it already. So if not, we will discuss just briefly about once again. So this is the one of the trendy topic in the industry. In the industry, in the sense I can say automotive industry. Okay. So why I'm saying trendy is it's a active safety system. So I hope you guys have remembered like we have discussed active safety and passive safety. Okay. So active safety in the sense after accidents, sorry, how to prevent the accidents, prevent accidents. Passive safety in the sense after accidents. This is the basic layman term which I can give you about these two safety systems actually, active and passive safety. So under active safety, it will come the ADAS. Under passive safety, which will come the airbag systems. I hope you got the difference between both of them. Correct? So after accidents, in the sense, if once the vehicle is meeting with an accident, so immediately within a fraction of microseconds, the airbag system will open it. Until that, the airbag functionality will not work. Correct? So that's the passive safety system. Active safety in the sense, how to prevent that to happen that accident itself, it is active safety. So predominantly it is working towards to stop that accident to happen it. Got it? So this ADAS system will come under that. So what it is saying, the term itself, it is saying that advanced driver assistance systems. So it will provide driver assistance. It will provide assistance to whom? To the driver. So that assistance also it is a little bit advanced. So that is the where the terms it came as a ADAS. So almost from last 5 years it is booming like anything. At least for next 15 years, this term will be there in the automotive industry. Okay, so now itself almost all the OEMs are coming up with this kind of features. So definitely for next 15 years there will be a scope for us to develop on the ADAS systems. Sure. So inside it, what it will be doing it. So this is one ECU. ADAS is a one ECU which will be having the so many kinds of functionalities. So which will provide assistance to the driver. That assistance might be in case of giving it might be kind of giving the warning, to the driver. I can say warning indication, or it might be controlling the vehicle itself. Controlling the vehicle itself. Got it? So what the project we are going to discuss is the ADAS issue right now. So ADAS is a technology, but for our ECU name itself, we named it as a ADAS. So you can call it as a ADAS ECU. That's fine for us. Okay. Any doubts?
No doubts.
Fine. So inside it basically. So inside this ADAS issue, we will be having the lot of features. If you guys have remembered any of the features which we discussed initially, that you can tell. First feature I can tell TSR, then AEB I can tell. Any other features did you guys remember?
ACC.
Yeah, adaptive cruise control. Any other features?
Lane assistance. LAS.
Yes.
LKS, I
LDS.
think lane keeping assistance, lane departure warning. Yeah. Tell me your other features also. I forgot it actually. What automatic high beam control?
Blind spot detection.
Exactly. Blind spot detection. Automatic blind spot detection. Something it will come. Yeah. Any other features? Wrong way alert. So this kind of nearly, to be frank, this ECU was supporting almost 64 features like this. Okay. Almost 64 features it was supporting. Okay. So out of these features, I think you guys refer. I don't want to repeat same content what we have discussed in the first class itself. Okay. Not first class, I think it was third or fourth class it might be. So if I see my material, so it was the last class for the lesson one. I mean the chapter one, embedded systems in the automotive. So we have discussed the pure technical stuff there. You can just go through that video once again. I don't want to repeat the same thing here. Okay. Now the main focus is like how we will be taking the requirements, how the requirements will be there, and how we will be doing the coding for that. Okay. The coding part we will be doing it. We'll not be doing it. I will be just showing on the real time, only for the TSR feature. So this is the main motto for me for today's class. I don't want to go through all these particular features and all. If anyone is interested, you can just go through and see it. Okay. So inside ADAS ECU, we will be having this kind of features implemented. How that features will be working towards and all. I think I have explained about this video, right? Not video, this diagram. If not, I will just explain that diagram very quickly. I don't want to take much time there. Then immediately we will enter into the, to the class, to the understanding, that's understanding. Yes, this diagram I wanted. Guys, these are the features which it is supporting. Okay, if you guys wanted to have the overview of it, you guys, you can able to see my table, right?
Yes.
Let me take this table also to there. Hey, no, yeah. If I'm enlarging it, it's becoming blur. I don't want to show you there. Here itself, you can able to see, right? So these all are the features which this particular this particular ECU is going to support. So we divided them into the light features, lane features, sign features, object features, and all those things. Okay, so you can see adaptive driving beam, auto high beam control, glare free high beam, camera based adaptive front control, front lighting control, camera based dynamic bending, driver alert system, lane keeping alert, lane keeping aid, road departure warning as per the NCAP rules and regulations, lane change warning, intelligent speed assist, traffic sign recognition, which is a TSO, wrong way alert, traffic jam assistance, lane centering, all these kind of features it will be supporting, adaptive cruise control, stop and go, pre-collision assist. So before going to do the any collision, any accident, then also it will give the assistance in that case with the AEB feature. Okay, distance alert, pre-collision assistance 1.5, 2.0 with the matured feature development. That's all. Okay, blind spot information system, bliss I forgot it. Okay, that full name I forgot it. Boundary alert, parking assistance systems. So all these kind of features it will be supporting. Okay, the issue whichever we are talking about right now. Okay, so now this is the car which it will be developed in the real time for the Ford vehicle. Basically, this is for the Ford vehicle. I hope all of you are able to see my screen. Correct?
Yeah.
So this is the real-time system. How we have development for the Ford vehicle for the North American OEM actually. So this guy is going to. We are always, if in case of ADAS, right? So we will be always talking about the radars and camera. Okay. So radars and camera, and also in some cases the ultrasonic sensors. Ultrasonic sensors. Okay. So here with the radars, what we will find out basically the distance. With the camera, what we can able to find out the object to type. Okay. So guys, this explanation again for you guys, it is needed before you are going to join with any of the organization. Okay, for that there is already pre-recorded video with the team. So if you guys are going to join in the next week, definitely you should have get access for that video by this week itself. Why? Because you need to see that video twice or thrice, then only you will be able to understand. So it will be having moreover what you need to it will have moreover about your project roles and responsibilities explanation. It's almost 2.5 hour video. Do remember this point, okay? Our team will be having that video. Just ask them to give the access if you are going to join in the next week or something like that. Okay, if not also they will be having the track of it. I think they will be sending to all of you guys, don't worry. So in this case for ADAS issue, basically we needed the radars, camera and ultrasonic sensor, right? So radars is finding the distance. So what will happen in case of radars is like if radar is there, if there is any object, it will be keep on transmitting the rays. If it is hitting any of the object, right? Any of the object, either it is a stationary object or the dynamic object, then definitely it will give the reflection back to the radar. Okay. So this time period, how much time it took to revert back with the reflection is what it will be depends on that value, the time value. It will be calculating the distance. So that is needed in our ADAS systems, and camera is to find out what kind of object it is. Okay, then ultrasonic sensors basically for the parking purpose we will be using. This cannot be sensed more than even for 5 meters also. So it's very short range distance finding we will be using. Okay, these radars we will be having the three kinds of radars actually. One is the SRR, short range radar. One is the short range radar. One is the MRR, mid-range radar. One is the LRR, long-range radar. So short-range radar, I hope it is for the up to 60 meters. It could able to find out the distance. It could able to transmit the rays. It is up to 80 meters. The long-range radars, it is up to 120 meters. Again, it depends on the manufacturers actually. they may give the more ranges also, but whatever the radars we were using, this is the range what they are having. And if you come to the camera, it will be the angle wise actually. It will be 50 degrees or the 100 degrees camera. So in this case, in this entire diagram, you could able to see all these three kinds of the radars, cameras, and ultrasonic sensors. Now just see very consciously here. So it will be very small objects here. Just try to see them. If you are not able to find out them, just let me know. Okay. This purple color one is there, right? This purple color ones. These all are the radars. So in the physical car itself, in this particular places only we will be placing the radars. This is the front fascia, we call it as, we call in layman terms, we will be calling that as a front bonnet or something, right? What do you front bumper? In bumper, just before bumper, you can see in high-end cars, there will be a small round shape thing, okay? That is for the radars. Camera you could able to see anyhow, but the radar you cannot able to see outside. It will be fitted inside what is that body control one, but it will be having the rounded symbol there. Okay, so this is the mid-range radar what we will be having there, and all these four corners it is showing, right? This is the short-range radars. Okay, and this is the front camera what we will be facing. Guys, you can able to see, right, the camera. This is the front camera what we will be keeping at the front windshield of our vehicle. Okay, this is the one which will be coordinately working with all the radars to finalize that when to apply the AEB feature or the traffic signs and all we are talking, right? All those signs and all will be captured by this camera along with the help of radars. So you can see here also the forward sensing, which is a 100 degrees camera. Okay, getting it? This is one radar, this is one radar, short range radars. Guys, getting a? If it is not able to visible, I can extend
Yeah.
this one also. That's fine. If I am extending, it will become difficult for me to explain it. That's the problem. If I make it this diagram little bit big, it will become little bit problem for me to explain. I hope with this you could able to understand, right? So when I was telling about the camera, so I was telling about the 100 degrees, right? You can see this is the focal angle which it can able to control. Correct? So this entire area it will be covering in front of you if there is any object is coming intermediately. See, for example, if you are going with the 60 kmph, if the object is coming here, immediately this system is able to apply the brake and all those things. Okay, this level of very deep discussion is happened in the for joining guys. So you can just have a look at that video. You will get to know about the more about the future level development and all, how the technically how the exactly the engineering concepts will be applied here is what will be explained there. Okay, so you can see like this radar sound, this is our ADAS ECU. Okay, ADAS ECU. So you can see how all those radars are connecting with the ADAS ECU. So all they are this orange color lines are there, right? All these are the CAN communication. Physical wires will be communicated with our ADAS ECU. Getting it? Ultrasonic sensors and these radars, they are in the purple color only. Even they are the, what is that? They are also will be connected with the CAN communication only. Even ultrasonics also they will be connecting with the CAN communication, or it might be with the SPI communication also. It's not mandatory to connect each and every hardware device, which is an external hardware device, to the your ADAS ECU with the CAN communication only. It's not mandatory to connect with the CAN. What I mean to say. Okay. So this domain controller is connected with your display. What is this display? Can anyone tell me? In our cars, basically we will be having the front one display, right? That is what the display what we are referring here.
Windshield camera.
No. It's not about the camera. It's
Dashboard.
the infotainment or dashboard. Usually we call it as a dashboard, but in the automotive development, if you are into the automotive development activities or testing, then they call it as a infotainment system, or the human machine interface HMI system, or there is one more thing here. I forgot it. It's okay, fine. So these two terms we will be using it. Okay, and that is what display we are referring here. So domain controller, in some cases, what is the need of this display system? Can anyone tell me? Let's take the example of TSR itself. In which cases the display system is needed for TSR feature?
Traffic signals.
No, in traffic signals, when it is needed. Why it is needed for traffic signals? Can you elaborate?
Speed limit boards. Speed limit boards.
Correct. I can consider speed limit. So if you are going over speed, okay, if your speed limit is 30 kmph, if you are going more than 30 kmph, in that case it needs to give the warning to the driver, right? For that, the warning where it can give? It has to give on the display only, right? Guys, you might have observed that if you are not wearing the seat belt, if any of the airbag systems is activated in the cars, then it will be keep on throwing that error. The seat belt wearing that what is that buckled is not buckled or not buckled. That symbol it will be showing with the red color and the HMI on the display on the dashboard. I can say. Did you observe anyone? In the similar way, if TSR feature is supported in that particular car, then it should show this speed limit warning to the driver on the display. Getting it? So in the recent cars, if driver is driving with the sleepy conditions, right? So first it will throw a warning on the display. If you're going into the sleep mode, then it will give the warning like vibration on the steering. So the warnings might be two kinds. Okay, one will be vibrations, one might be display warning also. Either way, it's fine. Okay. So now that's fine for me. So now, so you can see whatever the hardware we are using it. So almost the entire surroundings of car is covered. So with this short range radar, this much is covered. So this mid range radar, this much is covered. And again with the one more left short range radar, left front short range radar, this much is covered. Back left short range radar, this much is covered. Back right short range radar, this much is covered. Correct. And then in some places wherever we are unable to cover, these ultrasonic sensors are covering. And here back you can see the camera is covering. This back camera is for majorly for the parking. In some cases, if there is any crash is going to happen from the back end, also it will be able to detect it. Okay, so with this I can say that entire almost the back it is going to cover, right? And also you can see the front, the camera already it is serving, it is covering, and also short range radars and also mid range radars it is covering little bit more than all these things, correct? So now where it is left, okay, so the side it is left little bit, right? So this is the area where we call it as a blind spot, correct? So what do you mean by the blind spot? Can anyone tell me what is this meaning, the blind spot?
Driver cannot see the sides.
Exactly. So even if you are driving the car or your bicycle, then you could not able to see if the just in the blind spot area, if there is any vehicle, you could not able to see. Without finding that vehicle, if you are trying to take the right turn or left turn, definitely there will be a chances of collision, right? If it is very slow, if it is very slow in the speed, then it's fine. If it is in the more than 70 kmph or something like that, then there will be a huge impact for you and your partner vehicle also. Correct. So that's the reason you might be seeing here two cameras are placed in the, what is that? These mirrors. Correct. So these two cameras will be keep on covering that blind spot. So that's the reason we were discussing about blind spot detection system on blind spot detection system, BSDS or something. So that feature will be keep on taking the data from these two cameras. If there is any vehicle is in that particular blind spot area, then it will not allow you to take the turn. Okay, Now with this, I can tell that this entire 360 degrees of camera, 360 degrees of vehicle is covered with this electronic goods. Got it? So all these things will be, these radars, ultrasonic sensors, cameras will be input to our domain controller, which is ADAS ECU. So ADAS ECU will be placed in this particular area in the real time also. Getting it? So guys, any doubts in this diagram particularly? Guys, I know I have
No.
explained a little bit fast, so but still there is a one more video for this actually, particularly for this diagram, which is explaining about all these features. That's the reason I wanted to finish up with very fast this one. I don't want to spend much time here. We have a lot of other things to cover up. Getting it right? So with this system, I think you might be going to get to know like whatever the concepts you have learned so far, right? So this domain controller is there for this majorly whatever you are seeing here, all they are the embedded systems, which is our first chapter, I can say. Next, inside this domain controller, the language, one of the language which it is running is the embedded system, embedded C, which is a C language, which is our the second chapter. And the communication with all other communications happening with all other hardware objects, not only with the radars and all. This might be going to interact with the braking ECU and steering ECU and all other ECUs also. That communication, how exactly it is happening, that is with the CAN communication, CAN or LIN or Ethernet communication. But you might have studied about the CAN communication. So that is here the CAN communication need is there. So, and next topic was the UDS. UDS is needed if this particular domain controller or any of the radar or any of the camera, if it is not working, then definitely to know what is the reason behind that it is not working, how can we get to know? That is with the UDS protocol. Okay. And next, finally, the AutoSAR concept. So this embedded C is there, right? How exactly we have developed, on which basis, with what architecture we have developed is the AutoSAR architecture. So whatever we studied till now, all those things will be covering up with this project itself. Getting it? These are the major levels of concepts you might have studied in from last 1 or 1.5 months, which will be needed for one particular project. These are the concept wise, whatever the project might be. These concepts, if you know, then you will be the master in that project. Got it?
Yes.
Any doubts? If no, then majorly I will be showing you the Polarian tool now. The first what we are going to see is the TSR concept, okay? TSR, traffic sign recognition. Okay. So basically, let me share from other PC. Hey guys, I doesn't have access to this particular project actually, but what I will be doing, this traffic sign recognition requirements documents I have in the PDF format, okay? Requirements document I have in the PDF format. But this PDF, how I got it and what is the tool which we will be using is what I will be showing. First, I will be showing the tool. The tool name is the Polarian. Polarian, okay. This I cannot say is a Polarian. This is just like web browser actually. Web link only. Web link which we can use in the browsers. So these entire requirements and all will be there in the some database. This database, whichever the Polarian tool, this Polarian tool was developed by the Siemens. So similar kind of Polarian, we do have the doors and ALM and all those things. Doors and ALM are from the IBM. They will basically they will be developing the tools, right? And similar way, the Polarian is also one of the tool. Okay, so when I was having the access to this Polarian, I have just downloaded all this TSR document into the PDF format that I will be showing it. But for your better visibility purpose, I will be just showing little bit time about the Polarian tool. Anyhow, this tool again we will be showing you in the tool section also. That's fine. I will be resharing the screen. I hope you are able to see my screen with the Polarian. Guys, are you able to see the tool Polarian in blue color in the left side?
Yeah.
Yes.
Yes.
How can I make it bigger? Yeah. So, so this is the one web browser. Okay. So these guys, basically, to be frank, this is from the Aptiv actually. I should not reveal that company names and all, but this is for Hyundai Kia Motors project what they are doing for the airbag systems. Okay. So this is the tool what they will be using it for the requirement analysis and all those things. So you can see here the system. So are the requirements what it will be there, we will be having at the system level requirements and stakeholder requirements after software requirements and all those things. Okay. So this tool will be having a lot of documents and all. If I open the system requirements, so particularly for TSR you will not be seeing it. TSR I have the PDF as I mentioned earlier that I will be showing in the PDF format only, but it will be derived from this tool only. So if you see this one, okay, what is this? This will be running from some SQL servers and all those things, but that concept I'm not sure. Don't worry about that. No one will be asking that how that tool will be working and all in the automotive, as I mentioned from a lot of times. So this tool knowledge no needed, okay, but you should know what and all will be there in these tools and how we can utilize that tool. So you are just user of that tool, okay, you are not the developer for that tool. Okay, so inside system requirements, if you see, if we are having the DIDs, which is for the UDS requirements, which it will be having it. So it will be in the normal our Word document or PDF format only. Who is the author? Who is doing the modification? When he is doing the modification? What and all table contents it will be having and all those things. Okay. So you can see in the UDS, you might have seen the DIDs, right? Treat data by identifier. So that DIDs will be supported by these requirements. So unless there is a system requirement, software guy will not implement any of the requirement. Okay, getting? So all this, whatever, even single line of code, if you want to implement in the software, there should be a requirement from the system engineer. Okay, if he is not giving, then at least there should be a requirement in the software itself. There will be a couple of requirements which a system guy cannot give, but that can be derived by the software developer itself. That is up to the project. Okay, in this case, almost all the each and every requirement will be coming from the system engineer only. Okay. So these all are the requirements for the DIDs implementation, data identifier implementation. Okay. Getting it? So you can see CAN diagnostic services also. So our UDS services, what we are discussing about. So these DIDs and diagnostic services and all will be common for almost all the projects actually. You can just have an overview of it actually. CSRS in the sense system requirements specification, component device description, something it is there, CDD means, but you don't worry about this. This nomenclature is only for this project level. So it's depends on the projects how they will be calling it. If initially if you are not able to understand this nomenclature, you can ask your teammates. That's also fine. So here he is discussing about all the CAN communication, what and all messages he wanted to transmit on that particular issue and all. So this is how the requirements will be there actually. The requirements at each broader level we will be seeing at the TSR. I don't want to show you at for this project. Okay. So in these guys cases, empty seat learn. So if the seat, this is basically, as I mentioned, this is for the airbag systems. So if empty seat learn, how can the system learn that whether the seat front seat is empty or occupied? So that is the one feature for them. Okay. Power ignition, how the power supply will be provided to the ECU is what one kind of feature. This feature will be there for each and every ECU. Why? Because each and every ECU needed what and all the common things. The power supply is needed. CAN communication definitely will be needed, and the UDS is needed. These three topics will be there for each and every ECU. Okay. Then pressure sensor thing also one of the feature for them. Temperature sensor also one of the feature for them. So the future level they are having the software requirements to specification documents. Okay, got it right? So this is the basically the tool which we will be using it. So if you look at any of the requirement, right? So apart from this system requirements only, okay. So we do have the stakeholder requirements. You can see stakeholder in the sense from the OEM, there will be a couple of requirements which will be coming in the either in PDF format or in the Word document. That also they will be uploading into the Polarian for the better traceability. Okay, and then system requirements we do have here. They are not having any system requirements. I think from system itself, sorry, software requirements, they are not having anything. They are considering system requirements itself for the directly for the software implementation. Okay, and the design and all after software requirement illustration, we will be doing the design and all, right? That they will be capturing inside the Polarian. Okay, after doing the unit testing, the test cases and all they will be applying into the unit test verification. For integration and integration test, the test cases and the test case results and all they will be uploading here. And software qualification, software system integration, system qualification. All these aspects we will be seeing at tomorrow class. Okay. So all these test cases, test results, software development, software requirements, system requirements, everything will be there here. Why? Because everything will be should be bidirectional traceable. From system requirements to the software development, there should be a traceability. So that is how everything will be developed. Okay. So this is how the Polarian tool will be used for the bidirectional traceability as well as for the requirement database. Okay. Any doubts here? If not, then I will be resharing my screen again. Any doubts in the Polarian? If no, I'm sharing my screen once again back. Are you able to see my screen back now?
Yes.
So here, this is the PDF which I am having it. Let me see where is traffic sign recognition. This document and the document related code and all also I will provide it in the Skype itself. I will be sending it right after this class. If you guys wanted to, see it, you can just go through once again. Then that's okay, fine for me. Okay. So this is for Ford actually, for which were developed from the Aptiv. This content and all I will be removing. Just only the specific requirements I will be giving it. So this is for the traffic sign recognition feature. Okay. So these guys are the system engineers who were doing the modifications in this particular document. Okay. So in this document, we will be basically covering up, talking about this angles actually. So that's the reason they have given in front itself. What is the angle? What is the pitch angle? What is the roll angle? So the physics of your intermediate should be remember once again. If you are not able to understand, then you can just Google it once. Actually, that much basics I could not able to go back right now. So this traffic sign recognition is meant basically for the UK, Germany, France, Spain, Italy, Benelux, USA, and Canada. Priority two countries are the Austria, Switzerland, Poland, Turkey, Romania, China. All these are the exotic countries and all those things. So for all these countries, it will be supporting European. So as of now, what we have developed is for the priority one countries only. So whatever software it is developed depends on this particular requirements will be supported. This particular issues will be supported the vehicles which will be running in this particular countries only. So the software which we developed, if you are keeping that issue in the Indian vehicles will not be supporting at all. Okay. So here you can see list of countries, regions which must be reported by the vision sensor. So United Kingdom, which is UK, Europe countries, Canada, USA, Mexico. These are the companies must and should will be supporting it. Okay, and it should be able to find out the speed limit in the kph, kilometers per hour, and mph, miles per hour. So in our Indian roads and also in the UK roads, it will be at the kph, but in the USA it will be on the mph, miles per hour it will be. Okay, so basically you can think that how the system may find out in which country the vehicle is running out. Okay, so basically you might have bought this vehicle in the USA. Then after some time, if you are traveling this vehicle in the Europe, that also the system could able to find it out. Depends on the traffic sign boards itself. That is the one of the major opportunity to this vision sensor to find out that the vehicle is running in which country. Continuously for 1 hour, if it is finding the different signboards which are into the UK countries, then the system says that the country has been changed. You are entered into from USA to the UK. That kind of notification also it will give. Depends on the traffic sign recognition. Okay, what it is saying that what kind of signs it should be able to recognize and all those things it is giving it. So if it is saying anywhere, if you are seeing shell in the one sentence, that should be software implementable requirement. Shall, will, should be, if it is saying anywhere, and also I think that sentence should be noted it on the here also in the initial itself. Yeah, somewhere it will be there. Yeah, you can just read it once again. Okay, I no need to show it you the proof actually, but I'm sure it will be there. Okay, anywhere if it is sending, if it is saying that shall, will, or should, this is basically the key term for the system engineers. If they think that this is a software implementable requirement, that definitely they should mention it as a shall or will or should. Okay, then only we consider that as a software implementable requirements. Otherwise we will not bother about that. We will take it as information only. Information in the sense you no need to implement anything. Okay, so what it is saying that these particular types of signs it should be able to recognize the ADAS is what we are talking about now. So the prohibition signs, which is speed limit signs, speed limit shall be detected, speed limit cancellation signs, speed limit zone signs, speed limit zone cancellation, no overtaking, cancellation of no overtaking signs, and overtaking allowed and all those things. Implicit speed limit signs also, like expressway start, expressway end, highway start, highway end, city entrance, roundabout signs, no entry signs, stop signs, yield signs, crosswalking signs, all these kinds of bicycle street and all these kind of signs, it should be able to, find it out. And then the warning signs, which is the traffic lights, if in which color they are in, that kind of signs also it should be able to detect. Okay, dangerous cars, slope, pedestrians, bicycle, any animal range, forest area if it is there. See, wild animals shall be detected. In forest area, basically we will be seeing that wild animal signs, right? So that also it should be detected, depends on that the vehicle should act it. Okay, slippery road, icy signal. If there is any snow and icy signals, there will be a couple of roads which will be having always snow. If you see Mumbai and Pune highway, right? So definitely there will be snow in the this monsoon seasons. Okay, so this kind of signs and all it will be detecting. Directional, left, right, the arrow signs we call it as. Other signs is level crossings, motorway exist, advisory speed limit signs, no turn red signal. So this kind of signs will be, it should be able to detect. Okay. So here also it has given. So this what I can say is this speed limit boards are the sign symbols it is showing, right? So this will be different in the different countries. In Indians it will not be in this way. In the Europe it will not be different. In US it will be different. Okay. So you can see this kind of signboards it will be there. Okay. Let me take any one of the requirement. Guys, you can just go through all these requirements if you have any patience. These tables and all you no need to see it. Okay, it will be saying what is the confidence level, what false positive rates, what false positive negative, false negative rates, and all those things it will be saying it. But don't worry about that tables. Okay, you don't worry about it. Concept wise, you just learn it out. That's fine for me. So what it is saying, the system shall be able to distinguish if detected arrow is a valid for host and it is in driving direction or it's oncoming. So whether what it is saying, if it is finding any arrow direction, okay, whether that arrow direction is for your vehicle, whether or else if it is for the opposite vehicle. So that distinction it should be able to finalize. So how can you do that the kind of distinction? Can anyone tell me? Any guys, any input? So basically how it will find out it, at least in our Indian roads, if there is any arrow signs, then definitely it should be on the left side, right? In some cases, if it is any roadworks and all, if it is happening, if there is a divider, then on the middle of divider, which will be, showing the face will be showing towards our vehicle will be kept, right? Correct. The similar way it should be able to find out what kind of sign it is, whether that is for us or for, for to whom that is the opposite vehicle or what. Okay. Let me open the code now. So guys, and also this is how the coding will be there. This kind of different folder structures will be there actually. In my case, I will be mostly working on the integration folder, SWC. Here, if you see, LRAS will be there. So this is a file which I have worked mostly. Okay. Okay. So if I want to have all the functions list, I can just click on this one. So majorly you guys can tell that Notepad++ is the one which you have used it for the code editor as a code editor. Okay. So we were discussing about TSR, right? So the TSR functionality, the entire TSR functionality, if you guys are also looking at this particular file, the entire TSR functionality will be implemented in these 5 functions only. Okay. So if you see like what the requirement we were seeing it, so we were seeing like from the so basically before that I wanted to tell that the camera data is there, right? Let me tell in this way. So basically our ECU is there, right? This ECU is having the 2 microprocessors. Okay, one is from the Infineon, one is from the Mobileye. These two are the manufacturers of microcontrollers. Okay, Mobileye's microcontroller name is the IQ. Okay, Infineon's microcontroller name is the RX. Guys, just remember all these controller names and all. If it might be needed for you, someone will ask on which controllers you have worked on. RX TC3X. Okay, TC3X you can mention. Okay, so basically the objects and all will be finded by the camera, right? Camera data will be in the image format, right? So this image format, these images, the RX controller cannot handle directly. It is not having that capability to handle the images or the video. So that's the reason we are having the image processor here. Image processor. This is coming from the Mobileye company. The entire software also will be implemented by the Mobileye only. App2 is not having any control over this Mobileye controller. So we are just we will be taking that information to the RX controller, that's all. This Mobileye will be using the artificial intelligence, machine learning and deep learning concepts. So whatever the image they will be getting it, right? By using these concepts, they will finalize that this is a speed limit board. And inside this speed limit, the value is 30 kmph. 30 value and the units are the kmph. And the distance is the latitudinal position is 10.20.160.30 double quotation. Lateral position is this one. So all those information will be decided by the Mobileye itself. Okay, getting it? So if there is a if you are finding one of the signboard, for one signboard, for that entire signboard, this kind of information it is needed. Okay, let me show you that. So the confidence value, position longitude confidence, here you can see what is the embedded, what is the ID, whether it is on road, printed on the road, or just it is a signboard just placed besides the road. What is the lateral position, what is the longitudinal position, what is the vertical position, in the sense what is the height, what is the relevance of it, what is the color, what is the confidence. If we are saying 100% confidence, then only depends on that we will be taking the decisions. Okay, and then virtually it will be giving ID for each and each one of its particular signs. Why the IDs is at a time it might be it might be going to find out nearly more than 10 signs. Okay, 10 different signs also. To trace all this kind of information for each and every sign, it will be giving one virtual ID. This ID will be given by the Mobileye processor. Okay, getting it? If it is having any supplementary signs, let's like we have seen the previously, right? There is a speed limit sign. Apart from that, there is animal sign also. So that is a supplementary type 1. In some cases, we will be having the supplementary types 2 also. In that cases, what is the confidence for supplementary sign 1? What is the confidence for supplementary signs 2? If it is a speed limit value, then what is the value inside it? What kind of type it is? Okay, getting it? You can see if it is a basically the signs they have decided into the 3 types. Okay, traffic science, semantic science, and all those things. But you don't worry about that, okay? So if it is a traffic science, for all of them, the embedded means like it is a electronic one or the physical one. In Bangalore and all, you might be seeing that there will be some electronic science also. Okay, that particular kind of science also should be able to find out whether that is on road, what is the lateral, what is the longitudinal, what is the vertical. So all that kind of science it should be able to find it out. Okay, so all those science will be decided by using artificial intelligence, machine learning, and deep learning concepts. So the camera data directly it will be going to the mobile processor. Mobile processor will do the artificial intelligence, machine learning, deep learning. For example, if you are finding the 30 kmph speed limit board, so for that board, it will be giving all the relevant details, whatever we have seen as of now in the tabular format. Okay, getting it? Once doing that information only it will be coming to our RX controller. So the image processing and all will be done by the mobile processor. Okay, this will be coming in the either CAN message format or in the SPI message format. Okay. So for example, let's take if you are finding 30 kmph speed limit board, then if this is the speed limit board is 30 kmph or not, how will we find it out? By using the confidence. This confidence also will be derived by the artificial intelligence only. Okay, if this confidence is 100%, then only we will take the necessity actions in the RX controller. So basically we call this as a controlling microcontroller, or else we can call we are handling the controlling algorithms in this RX controller. Okay, so from IQ or from the mobile ECU or mobile microcontroller, we will be getting just the information. Okay, also from the radars also, radars will be connected somewhere, right? Radars also will be keep on sending the distance and all. Okay, okay, so that also we will be taking the data. So for example, if it wanted to apply the brake, okay, so if there is any pedestrian is there, how much distance is there, whether he is a pedestrian or not, if there is any chances of collision, then only we need to apply the brake. That applying the brake, the decision will be taken by the RX controller. Then it will give the controlling to the braking ECU. Okay, got it? So let's take what we were discussing about this 30 kmph. Okay, this TSR is traffic sign recognition feature. What it will do, if you are finding 30 kmph speed limit, if you are saying that 100% confidence by the mobile processor, then it need to look at what is your vehicle speed, right? If your vehicle speed is 70 kmph, then definitely it needs to give the warning, right? This comparison and giving warning will be happened by the RX controller. Okay, our part now, what I'm trying to say is our part is implemented. This TSR traffic sign recognition is there, right? This entire feature will be like taking the input from Mobileye will be implemented in the RX controller as a one of the software component. Okay, doing the artificial intelligence will be happened by the someone else, and taking the controlling algorithm will be developing the controlling algorithm is what we have done inside the RX controller. This part you should be understanding and you should be remembering it. Definitely tomorrow if you are joining somewhere, then they will ask what is your exact role. Then this part is what you should be able to tell them. If you are able to success in this explanation, then you will be then you will be succeed in this in their organization. You will definitely you could able to perform whatever the operation or whatever the task they will be going to give you. This is particularly for the development guys. For testing guys, there is some project explanation that they will be that I will be asking them to provide you the video, okay, pre-recorded video. Okay, fine. So now we are discussing about this feature, how we are exactly we are developing it. Okay, so what we have seen it, we will be seeing at the two requirements. One is like how we will be deciding in which country you are there. Okay, The other one is the traffic sign ID recognition. I mean, like a speed board or any other signs, how we are recognizing them. Okay, so these requirements you can see like SNS gen country is what from where it will be coming is like we will be preparing this signal, but Mobileye will be providing the signal information. Okay, com region a code v underscore it will be providing it. So and also I wanted to tell that depends on the sign boards. Okay, depends on this shape and size of the signboards. This artificial intelligence and machine learning will be deciding that your vehicle where it is, in which country it is running. Okay, that is what I was telling in the prior also. So if you have bought this vehicle in the USA, if you are entered into the UK, then it could able to find out that your country change your country is changed by using artificial and machine learning concepts of Mobileye. Okay, so now what where is that? Now what is our role is here is like the signal whichever it is coming from the Mobileye, we will be taking that and we will be providing that information to the gen country, SNS gen country. That is one of the signal name which we have discussed in the C language classes. These all are the we will be using as a coding parameters. Okay, so here also you can see now this is a just signal mapping what we are doing here. Whatever the signal you will be receiving from the Mobileye, that you will be mapping it to the your Ford signals. And the source, who is the source? The Mobileye is the source. Okay, so this signal type will be the unit 16, means it may have the 16 bits of information. Okay, by default if you are not getting any of the data from Mobileye, then by default it should be 0, which is a rest of world. If it is 0 means in this SNS gen country, if the signal value is 0, which means that it is in the rest of world. Getting it? Any doubts? Okay, if you are getting from the from the Mobileye, if it is a 0 means, then here also it will be 0. If it is a 1 means, yeah, here also we will be mapping it to 1, which is a Europe. If it is a 2 means you are in the Gulf countries. If you are in the 3, if you, the value of this particular signal is 3 means, then you are in the USA. If it is a 4, Canada, 5, Japan, 6, China, 7, South Africa, 8th Korea, 9th Australia and New Zealand, 10th is the UK. The value 10 if you are getting from the com region code in this variable, if the value is a 10, then the ECU will be decided that you are in the UK. Okay, getting it? So this part we will be seeing it now. So I think when I was telling about the C language code, I was also telling about this signal also. So in the system requirements, if they are mentioning any of the signal name, definitely for the software development also you need to use the same signal. And in the system requirements or the software requirements, they will be telling that who is the source of your requirements, from where this in this case at least this is from the Mobileye controller. But if it is not from the Mobileye also, within the same ECU if it is coming also, which software component is going to provide this information also they should be mentioning. So guys, and one more thing, this tabular format is not mandatory for all the projects. It's up to them, the system engineer, however they wanted to maintain it, they can handle it. Okay, particularly for this project they are handling in this way. For this was the easiest way method of doing the system requirement analysis for them, system requirement development for them. Okay, now if I search with this name, then I will be going to get that particular parameter name in my code. Okay, you can see here. So this signal name should be there, but prefixing and suffixing might be anything else. That doesn't matter. But exactly with that signal, there should be a name. Okay. Guys, getting any doubts? Or Is it making any confusion for all of you? Fine. So you can see LROS is a component name what we have prefixed here. So SNS gen country, by default auto variable init we have given it. Auto variable init is a macro which is a value of 0. Why are we giving it? Why we are giving this value is in the requirements if you see they have mentioned default value should be 0. If you are not receiving any of the data from mobile, by default it should be 0. For each and every signal whatever you will be implementing there will be a default value for it. Okay. So this RTE write, we have seen it in the AutoSAR class. This is a RTE port, which is a write component. This guy is the sender. Someone else might be requested this data. So that's the reason we are keeping inside the RTE write. Okay. So next you can see control G 34356. So here again you are modifying this signal. So if LROS SNS gen country, no, I am missing something. At line number 387, you can see that LROS gen country is getting updated by the market config country. How exactly it is getting updated by market config country is it's not there. Basically, this market config country is the one which is carrying the country information from the mobile. So that is the reason that value we are updating it to the LROS SNS gen country. So now if for example, whatever it is bringing that value directly, we will be providing it to the SNS gen country. Okay, now you can see this line number 354 actually. Yeah, whether we are just checking whether it is in range or out of range actually. Okay, here you can see it whether it is inside the within the range or what. So within the range or how can I check is like in the requirement itself we can see that the range should be from 1 to 10, correct? If it is out of that, then definitely it will be the out of rest of world. Okay, that's the thing that what they have mentioned it. Okay, that is what that is how we will be developing. Almost we will be having for loops, if else loops, and all those things only. So this rest of world value will be I think what is the find all in the current document. Its value is 0. If it is less than 0, and if it is find all in current document. If it is out of 0 to 10, then it will be telling that as rest of the world. It should be either in between 0 and A, including 0 and A. If not, then definitely it will be saying it is out of world. So this is the first requirements what we can see here. And the next requirement what I can show you is here guys, these are the very simplest requirements which I am showing. I don't want you to make confusion. So you guys see the other final video before you joining for any of the company. There we will be explaining about this entire traffic and recognition feature. There you will get very good idea what is this feature is about. Okay. So now you can see the traffic sign recognition, regular signs, this function. So the next consecutive requirements will be for this only. This is a little bit complicated one, but still if you are able to understand this is well and good. If not, I will show you the next requirements. TSR ID also I don't want to share. You can see this sign type. Okay, so this sign type. So from Mobileye, what is the thing we will be receiving is TSR underscore sign name is what we will be receiving it, and then we will be sending this SNS sign type from the LROS. LROS is our software component name, or else you can call it as a TSR also. Software component name is fine. Okay. From TSR you will be getting the UINT 16 parameter, but from LROS you will be preparing only UINT 8. Why? Because the sign types max to max only up to 255 it will be there. Okay. So you can see here from the Mobileye, you will be receiving this values 0 and all those things. If you are if you are not receiving any of the data, by default it will be 0. If you are receiving any of these things, then it will be speed limit start. With the values, if you are receiving any of the sign, then that means that is a speed limit boards. And no passing start. If you are receiving this 200 value from the Mobileye, then from the LROS you will be passing 3 as a no passing state. Motorway start, motorway end, all this kind of stuff we will be doing it. Okay, let me show you this particular sign. So here itself, I think you could be able to see it. So here, sign on road, this is for sign height. You can see here I have given the comments here. You can just go through after this class also, that's fine. Sign variable, for sign variables we are doing this if logic. For finding the embedded we are doing that. For relevancy we are doing it. For supplementary confidence we are doing that, and for value we are doing it. For confidence we are doing it. For longitudinal position this particular logic is implemented. For longitudinal, that one. Signs above on road, this logic, sign type, whatever the requirement we were seeing it, that requirement is implemented here. You can see in the switch case we have implemented from IQ I will be receiving from TSR sign name. So that TSR sign name, if any of this 10, 20, 30, 50, 60, 70 or whatever the value it will be, from LRAS SNS sign type, you will be preparing that as a speed limit start. You can see here. So from IQ, from left side the table, in the table left side one is the from IQ, from in right side one is the LRAS. So this is just one-to-one mapping. Okay. So from Mobileye, if you are receiving 0 to whatever the enumeration values, in LRAS you will be keeping that speed limit start, which is a value of 1. So here you can see speed limit sign start. You can see the value of it will be the 1 only. You can see here. Getting it? So the similar way you can see for each and every IQ inputs, how your TSR feature will be mapping the sign types will be what this requirement will be saying of. Okay, similar way you can go for all the remaining requirements also. Immediately after this class, this coding file and this requirements document I will be showing, I will be sharing on the team in the Skype. Any doubts here?
No.
Fine. I think these are the most of the things which I wanted to take care in this today's class. So this is what we have seen it. You can see on the first page itself what we have discussed today. So we can see that ADAS project we have discussed what is the ADAS project and why exactly the ADAS project is that much becoming importance in the automotive is what we have seen it. Not that much deep, but you can see in the next videos also. And understanding of the couple of TSR requirements is what we have seen it. And we have also looked at the code for your basic understanding. I cannot say this is a very deep learning, but you can just go through all these requirements again, once again to understand all of them. Okay, I'm sure guys it will be very difficult for all of you to study all these things, but slowly you need to spend more hours to understand all this stuff, then you will be succeeding over this automotive concepts. Fine. Any other doubts? If no other doubts, I think this is the first class where we are on the time. Fine. I hope Satyagopal, I did not saw that message. I hope you came back to the class again. I think so. Fine. If no other questions, I think we are good to go ahead for today's. We will end up today's class. Tomorrow we will start up the tools classes actually. Okay.
Yeah.
Fine. Thank you all. Bye bye. Good night.
Thank you. Bye.